Alright, this is a guide to get you started with the flip-flop lab experiment 7 from your textbook. The first part was to use the cross-coupled NAND gates to create an SR latch. So here I've done that. Some of the key things you need to know in order to use this, what I'm going to ask you to do is create a sub-circuit with this. So up here under circuit, this is a sub-circuit. You can do insert sub-circuit. The first thing you want to do is start out with a main circuit. Whenever you switch back and forth. So here the main circuit, what we want to do is create two DLatches in order to create a falling edge triggered flip-flop here. So as we go from 0 to 1, so that's showing this. So let's go back to our DLatch, which was the first sub-circuit I made. So the first sub-circuit I made was the cross-coupled NAND. So this cross-coupled NAND, some of the key things you have to do here is, for these are two inputs and these are the two outputs. You want to label the inputs and outputs in order to use the sub-circuit. So what you can do, if I click here, up comes the properties. So I labeled this S. So this here is where you want to make sure you label that in S, or you won't be able to see it in your sub-circuit. So that being done, and then of course, label this. Click over here. You want to make sure you label that. I labeled that Q. So each of these are the labels that I inserted using this properties tool. From this DLatch, from this cross-coupled NAND sub-circuit, went over here into the DLatch, and then you can do a circuit, insert sub-circuit, and insert the cross-coupled NAND. So that's what I created it with a cross-coupled NAND that I created from scratch, but then I used this sub-circuit here. So I'm going to delete this because it's already done. So I'll delete that one, and you see these two. This is just the cross-coupled NAND, and this is creating the DLatch instead of using an inverter, just using two NANDs here. Hopefully you did this for your homework. Notice though, when I did the cross-coupled NAND sub-circuit, it's a good thing I had these labeled. The first time I did this, I thought S was going to be on top and R was going to be on the bottom, because this up here is S and this is R down here. But now I have Q on the top and Q prime on the bottom. I haven't figured out how to order these yet in the sub-circuit, but when you put the sub-circuit down, it has the S and R labeled. So this then my R goes to the top and my S goes to the bottom. And then for my DLatch, since control is a 1, as I toggle the 1, goes to 0. Since control is a 1, it goes right through. My Q becomes 0. The Q is on the top for both of these, and then if it goes to a 1, it becomes a 1. If my control is a 0 and I toggle D, nothing happens. If I leave it at 0, as soon as I set control to a 1, it goes to a 0. So this is part of your lab. Then we wanted to use two of these, and again, I make sure you label where you have your inputs, where you have your outputs. So I went to the main circuit, and I'll just do OK, because what I changed I don't care about. And then I have two DLatches where I have Q. Now my Q in the DLatch is on the bottom, my Q prime is on the top. Again, I'm not sure how to control that. You might be able to figure that out. But since they're labeled D and C, Q prime and Q, I can then use them in here. So I have this would be the Y. I could label that as a Y. If I want to just label the wire here as Y, then what I want to do is I can use under the miscellaneous this text symbol, and I can put this text symbol here, and I can call that Y, and that's my Y right there. And then use the two DLatches, and now I put a clock in here. You can also just put in an input. First you can put an input and toggle it. Once you put the clock in, that's what we want to do to, since the clock is going, see, we can't necessarily tell whether it's rising or falling edge yet, but if I go and insert my flags, which are also under miscellaneous, I can put my flags over here, where and then I'll put it, and I can detach the. It's kind of funky doing this, but I'll attach that to my output. I probably should have done the clock first. That's running along here on the bottom, and then I'll flag the clock. That's still going to the clock there. So I have my F1 and F2, and then you can change these so you can read them. So that there's my output. When I change my input, you see that it's in fact falling edge triggered. Then so you can you can do the oscilloscope part of this lab. So you'll also want to look at, for example, you want to look at Y, I think, in this part of for the oscilloscope also. But the other thing you want to do is change the name of these flags. So this is clock. So if you click on the flag and go down to your property editor properties, we'll call that CLK. I think that should work. Did that work? Enter. Okay, no, that didn't work. A label clock over here. This is where you want it to. We'll call this CLK, and then notice it changes here, up here on the flag, and it changes down here, and over here we can click on that, and we can call that our Q, I guess. Q. Whoops, that didn't work. Cancel. Q. Now it worked. All right, so hopefully with this you can figure out how to do the oscilloscope part of the lab. When you're doing the part of the lab where you're collecting data of zeros and ones, you're going to have to write them down. There is a way to use additionally, there is the test bench. So I'll do a little video on the test bench. There's also, if you want to look at the test bench yourself, remember all this, if we go back to all the documentation, if we just go to our circuitverse.org, you can get the documentation for all of this. So this is just the circuitverse.org. If you go under documentation, all in here, I guess I was there before too. All of this is documentation. So the test bench is here. We can create a test bench. This is what we'll do with HDL also, where you just basically give it a table of changing inputs and outputs, and you get a table table of inputs, and you'll collect the outputs. All right, that's it for this video.